Quantum mechanics, accounted by Schrödinger's equation, tracks the change in properties such as position and momentum for every particle in a system by considering them to be different. It's like tracking every dollar during transactions. We don't care which dollar is which, only how many dollars end up in whose bank account. Not only is it inefficient, it is prone to double counting. As all particles of the same type are identical, the equation gives wrong answers. The solution to that problem, of course, is to instead follow the change in balance of every bank account. A field is a quantity assigned to every point in space, aka bank accounts. This is a photon propagating through the EM field. Every point on the field has been assigned a value which changes in the photon's presence. Rather than thinking of photons as the cause of excitation, we can describe a photon as an excitation in the EM field. A photon is energy, and so are all other particles. Seems fair to describe each elementary particle as the excitation in the particle's respective field. Imagine a particle vending machine. A certain type of particle costs a certain amount of energy to be created. Put twice the certain amount, get two particles. Every oscillation or excitation in the field has to have an amplitude or value which is an integer multiple of the minimum amplitude the field can possess in order to create a particle. The third law of thermodynamics states that absolute zero or complete absence of kinetic energy cannot be achieved whatsoever. This law demands even empty space to have some energy. QFT agrees by predicting fields themselves to have a minimum energy state known as the vacuum state and the minimum energy known as the zero-point energy. We can explain this by the existence of particles that borrow and return energy from and back to nothingness in the process of the creation and annihilation. It can be violated, but for a short time interval only. The energy-time uncertainty relation confirms it. This is why the lifetime of these particles is too short for us to measure. All we can measure are their ghostly marks left on the universe.